What's going on, everyone? So somebody sent me this video and said, this proves flat Earth. It's 600-mile shot to Mount Shasta. There should be 17 miles of drop hiding it. So I went to check it out. This is the video. It's a clip from flat earther JTolan Media. He filmed this from a flight between LA and Chicago using a Sony a6000 converted to infrared. I kind of watched through it, saw a few parts that were interesting like this. This is definitely a doable shot, 65,000 feet, Mojave Airport, seeing the Pacific Ocean. It's like 85 miles. If I recall, at 35,000 feet, you can see about 210 miles on the globe Earth. That's the globe Earth's prediction. And then he goes through a few more things, shows a lot of things. There was a cool shot of like Zion from the air at some point. He's still talking Arizona, or there we go. So Colorado City, Zion, Utah, shows kind of roughly where he's at and which direction he's looking. He did use this map, which was kind of interesting because he panned sideways. So he shows this, and this butte lines up. That matches that shape perfectly. So I didn't check the distance. I don't know how he thinks he's seeing a 1 billion mile tall smokestack, but he pans and pans and pans and says Salt Lake. Salt Lake is actually like behind these mountains. So I don't know how he's seeing Salt Lake over here from behind these mountains, but that's beside the point because the observation that we want is the Mount Shasta one. So he keeps scrolling. He shows this picture and zooms in really quick. And then that's kind of it. So what I did, I got a screenshot of it right then. So it says Colorado City down here, Mount Shasta up here. Let's start by verifying that it's Colorado City. So it's funny. It's named Colorado City. It's a border town that's actually mostly in Arizona, a little bit in Utah, but it's called Colorado City. So let's see, looking at this, we've got this valley or this canyon, the city itself, these mountains that kind of curve in and around. We'll compare it to here. So Colorado City, the mountains curve in and around, and we've got these. This is defined peaks. So it's like a peak, a little drop, a peak, a drop, and then up to this plateau. And when we look at it here, we can kind of see that peak, drop, and then up to this like plateau. So it's definitely Colorado City. Now let's go find Mount Shasta. Okay, so what I'm going to do is use Google Maps for this instead of Google Earth, only because more people have Google Maps and I can talk about it. Right click here, hit measure distance, and then we will find Colorado City again. And go to Colorado City. So it looks like 580 miles. He is up in a plane and back a little ways, so we'll give him some distance here. You got to go back pretty far to make it the 600-mile claim, but we'll do the math for this. So observer height, we know he's in an airplane, so he's probably flying really close to 35,000 feet. We are going to give him his 600 miles, and then Mount Shasta's elevation is 14,162. Yeah, so I mean, let's look at that drop. 92,160 is 17 and a half miles. So yeah, that is, if we did even standard refraction only drops it to 81,000. So no matter what refraction we put it at, unless we go crazy absurd, ultra high, never heard of refraction, then we can see it, but we won't worry about that. So yeah, I guess JTolan did it. He took a 600-mile picture. But instead of just believing that, let's double check something. So we know he drew this line on here. This is a fun little line that he drew. Now we got Mount Shasta over here. I don't know why. Oh, that's the town of where it's dropping that pin. But we'll put the pin there. And then we'll go all the way back to Colorado City. And looking at his picture, he put the pin about right here. Okay, so we saved our line, and then he's looking across that way. Now I see a problem immediately. When we look at his picture, he's this is what I love about mountains is it beats the like, oh look, I looked over flat water and you got to just guess at where I'm at. With mountains, we get fun geometry and topography. Every ridge is unique. So we know that his pin is about his little line. It starts about there where we put our pin. then the curve happens, and then it goes across those two peaks and a little up that slope. When we look at at the line that actually goes to Shasta, it doesn't go over that mountain. That's interesting. So let's draw a line in that direction. What we're going to do is put a pin drop pretty much the same spot, and then we're going to get where it lines up, kind of where we assume it's close to lining up with on that hill. So right there. And it looks like we're sitting at about 131.2 degrees. So we will just drag this thing out at 131 degrees. We're going to go like 300, 400 miles. So we know it's 131, let's say 0.2 degrees. It was close to that. Save that. Okay. So now let's go into the ground. Let's compare those. I lost it. So we're going to go to about 35,000 feet. This is 32,000 feet. I need to change this angle. So I'm going to go down a touch more so we can kind of see what's happening here. We're going to shrink this thing and blow it up. So looking at from the pin, it might be, he was probably up that hill a little bit more, but from this pin drop, and across that looks about right. We've got this mountain ridge here, which kind of looks like that. Then we've got this little plateau thing. Okay. The canyon. So it looks like he is not aiming near Shasta, which is that direction. He's aiming off somewhere this direction. So it looks like he could be lying. Let's see what we can find. So we've got back here, it kind of goes across these mountains. We've got this ridge here. I think I'm actually a little to the right of where he's aiming. Because if we go, this mountain here is this one. That's 100% this. And then he's looking just over this way from it. So I think he's actually seeing one of these two peaks. And that would make perfect sense. So we've got Cave Mountain and Cleve Creek Baldy. So let's see, Cave Mountain, Nevada, elevation, Baldy, elevation. Okay, so I like this peak bagger site. And the reason why I like this, it gives coordinates. So what we're going to do is actually in our Google Maps, actually, we'll do that here. So let's plug these coordinates in. So this is, yep, there's Cleve Creek Baldy. And now let's grab the one for Cave Mountain to confirm we have the right Cave Mountain. Yeah. Okay, so we've got both of those. Now we have the elevation. So Cave Mountain, Nevada is 10,749 feet. This one's 10,937 feet. So let's go for the shorter mountain. We're going to measure the distance from the farther mountain, but then we'll use the elevation of the shorter one and see what happens. So we'll go, and we'll give them a little bit of extra distance here. So we're looking at 187 miles. So 187, that's funny. So he thought he was seeing 600 miles. He's seeing 187. And let's use the shorter mountain peak of 10,000. Oh, so that's interesting. When we do the proper stuff, that's with zero refraction. When we do the proper stuff and proper measurements and everything, we get a globe Earth yet again. So this seems to be, I'm going to put this up because I'm going to put some words over it. But this seems to be a pattern with flat earthers. They make these claims. This is Mount Shasta from 600 miles away. It sounds like proof of flat Earth. People blindly believe it. And but it doesn't match. We know for a fact it doesn't match. And we actually just found the real mountain that this is 187 miles away. One of the two. we can say it's one of the two mountains 187 miles away, but the angles don't match for it to be Mount Shasta. So I'm curious at why JTolan Media is blatantly lying to people. Why he feels the need to make things up like this. Here's a side-by-side of his photo with the line drawn in it that he drew, and the heading on Google Earth, and how the topography doesn't line up with the line he drew. So we had to adjust and find the real answer. So once again, when you actually test the claim instead of just repeating it back, the globe seems to work every single time, and Flat Earth doesn't. Always test the claim.